All right. We need to broadcast it to all connected clients. How do we know who are the other connected clients? Possible approach be using dynamic supervisor which children. It would work. Yeah. That approach leaves something to be desired. We'd only be able to get all the connected clients, but not do things like get the process for a specific client identified by its username. This means that we wouldn't be able to implement direct messages, for example. A perfect tool for this is Elixir's registry. Registry is essentially a key value process table. You can register processes in a given registry under a key and also store some additional values under that key. Then functions in the registry to look up processes by key, dispatch messages to all processes under a key. Registry takes care of cleaning up processes that stop, regardless of whether they stop gracefully or not. Okay, that solves the problem there. For now, we'll register all processes under the key broadcast, which will allow us to implement bub-sub like dispatching. We'll also start another registry to check username uniqueness by registering each client process under its username as the key. We'll guarantee that no two users can use the same username. Cool. What is an agent? Also, there's a, oh, it's down here. Okay. A set ETS table would have also done the job and likely faster than an agent. The true advantage of using a registry here is the registry is tailored to be a process registry. Yep. Okay, this is perfect for our use case. We don't have to worry about users that disconnect and keep the username they were using taken. As soon as the connection drops and gets freed up in the registry. Okay, cool. Whoa. You can put a whole picture in there? That is huge on my screen. What is Gigantify? What's up, Brian? How's it going? That is crazy. I've never seen Gigantify an emote before. I also didn't know there's an Erlang emote. That's fun. Sorry, I'm a little blown away by this. Very much today I learned. Please. I guess I need to check out this person. Not even sure how to say it. Shrira? Shriraya? Or are these yours? I guess they could be yours. Shriraya. Okay, anyway. All right, so this is in our application, which I don't think we have anything like this yet. So I'm guessing this is this lib chat application, which I think is like a new thing. Add acceptor. So this is the acceptor thing. Okay, so I think that this is, okay, we start a registry, broadcast registry, and a username registry. It's unique. Yeah, there's also what is it? And I think it's this. Yeah, NP network programming in Erlang and Elixir, or Elixir and Erlang, I think is the order. Okay, so we need to figure out how to do this registry stuff in Erlang, I guess. Yeah, we used a duplicate option for our broadcast, which means we'll be able to register multiple processes under the same. Goodness, look at these. We'll be able to register multiple processes under the same name. For the username registry, instead we have the unique option. The whole point is to have unique registered, right? And then we just register. Wait, what is this? Now we move on to registering connection processes once they receive the register message. Modify our existing handle. What's weird to me is there's no PID here. This one makes sense. Oh, it must just know. It must just assume that it's like the self that's registering. So like if you use this register function, it's like I'm going to take self and register self in the broadcast registry, I guess. Now the question, I'm an Erlang. I'm more familiar with Erlang than I am Elixir, so I'm kind of like converting this book into Erlang currently. But like the syntax is just syntax, right? Like conceptually the languages are more or less equivalent. So you just need to kind of like understand how they work. So I'm unfamiliar with this registry thing, but I'm pretty sure something like this exists in Erlang as well. I just need to figure out how to deal with this uniqueness bit. Okay. Yeah, so on line 6, directly matching OK, return for the registry called. We're taking a shortcut here in production code. You should handle this possible case by doing something like sending an error to the user and giving them a chance to try a different username. Sure. However, that would introduce unneeded complexity for the test case. It makes sense. So let's have the connection crash altogether and not care too much about it. Totally agree. Because it does like we're not writing an application, we're learning about this. All right, and then when we handle the broadcast message from clients, which is like, okay, so there's two messages here that you should be aware of. There's a register message and a broadcast message. A register message takes a username and registers that username as like someone connected to our chat service. And then this broadcast message contains the current user's username and then the message that they're trying to send to the chat service. So here we can say registry dispatch on broadcast if the PID is not the sender. Totally makes sense to me. And then we just need to handle the broadcast message in the connection. Yep. Cool. And then this is just a test. Nice. All right. Nice. Yeah, like I don't know what else would it do. Like I don't think it can't possibly do anything else. So, if I recall correctly, there's a PG module for this. I think this is the one we're looking for. And then we need to just figure out what is its shape so that we can like create these groups. So I need to understand what's the difference between a local Yeah, so this just gives you kind of the same thing. There's a list of members in a group. There's a join function, which you pass a name and PID or PIDs. You can also leave. Okay, subscribe the caller to updates for the specified group. Start. Okay. So one thing I don't see here is like the convenience methods that are around the registry. So like for example, we have no mechanism for ensuring that our groups are unique. Yeah. So or well, I didn't know that. Registry is just wrapping ETS tables. So we could probably do something similar here using this PG module. It's just that we're going to have to do a little bit more work ourselves. because like we don't have a mechanism for saying like only only allow this join to happen if, for example, oh, we can't keep usernames either, can we? We are only keeping PIDs. So maybe we'll just ignore the username part of this and deal with that later. I suppose we could also just create an ETS table, like a global ETS table, and then just store in ETS, which is another option. Since this thing can't really handle our names use case. I feel like that's doable. Both of those things are doable. We could also just like crib from the register implementation, right? How complicated are they? Yes. Yeah, these don't look very complicated at all. So I feel like, first of all, this should probably just exist in Erlang, shouldn't it? I feel like it probably does. In fact, I could have sworn I saw a library for something like this. gproc 10 months ago? What does this do? Man, that shaking Elixir thing is in my periphery and is driving me nuts. That's funny. Counters? No, don't worry about it. We'll survive. Promise. Um, all right, there's like no examples here, but this looks like effectively like pub sub. Um, gproc register. P1 name means property, local name. They're funny. Are there just markdown docs? Okay. Registers a global unique name. Okay, I'm really feeling like this should probably just exist as an Erlang library, but I don't know how to find it. So I think we're just gonna kind of like ignore the user case register thing since there isn't a convenient tool to do it and just do the process registry. So people can use the same username in the chat application and then we'll just make the broadcast work because we can do that with built-in the built-in PG stuff. So I think that's what we're going to do. Because I don't really want to spend too much time thinking about it. It's not like worth it for the concept. You know what I mean? Like if this just existed, we would just use it, and like we totally could write this. I just don't want to do it now. All right, now the question is, which one are we doing? We need to do the acceptor, I believe. So the acceptor is what pulls in the process and then starts the child acceptor. And oh, but this isn't where we call the register function. The register function happens in the chat connection. So somewhere in here, we have a register username, and then what that's doing is setting the username. So that's where we have this handle message function that basically checks that the username is currently unset and then sets it. So here is where we would need to do PG And we want to, do I need to like create a group, or can I just join? Like, can I just freely join a group and that's fine? Or does the group need to exist? Let's see. Is there a function like create group start that starts an additional scope? And then this is starts the default PG scope within the supervision tree. So I'm guessing that we can't. Okay, we should just try it, right? Like, there's no reason not to. So rebar 3 shell. We need to run this PG start link function, I think. Start link. And then we should be able to write like join PG join. And this is like, what's a group? Is a group just an atom? It could be literally anything. Okay, so this is going to be our broadcast group. And we're going to add self. Okay, that seems fine. And so then we can do like PG get members broadcast. And there's our process, I guess. I mean, I assuming self is that. Oops. 236. Yep, there you go. Okay, cool. So that's all we really need to do. So in our chat, where is this started again? TCP server acceptor. In our start link function, we also need to do PG. Wait, no. This isn't it. In our supervisor. Here's our supervisor. Oh, it's called chat acceptor. Wonderful. So in here, we'll just start this here. Honestly, no. No. We'll just start it in here. All right. So strategy 1. No. I don't need to do this here either. App. What is the thing? Isn't it called like application? Sorry, I forget what this thing's called. It's just, isn't it this? That says what starts? There's PG. If I just, can I just put that there? Let's find out. Source. Could I just say PG like this? Okay, no, because it's not an app. Good to know. We are learning. So I do need to start it here. So not here. Here. This is the outer supervisor for our chat application. 141. ID is going to be the broadcast registry. PG, I guess. And then we'll start PG start link with no argument, I believe will be enough. So that will start our PG for us. And then over here, we can see join broadcast self. And that should get us to, that should handle our register message. And then when we broadcast, we'll deal with that in a second. So I'm pretty sure that's all we need to do. And then we could try to, oh wait, I don't even have a client to send this register message. This is going to take off TCP. Maybe I can just test this really quick. Let's try. All right, so then we do TCP. No, we do chat acceptor. Hey, SJM. How's it going? Chat acceptor, start link. And then in theory, we should be able to do this. And the question is like, can I actually register here? Oh, invalid data. Okay. So 1 and then our username. So invalid data. Fun. All right, so I think we're gonna have to debug this a little bit because clearly that's not working. So the way this is supposed to work is we're supposed to be able to do like chat. Let's try this. Protocol, register, think. Right. We also need the size. But I guarantee we can't write 111 chiroptical, which is a problem. So we probably have to do this. How do I even like test this? This is hard. I'm gonna have to figure out how to test this later though. Okay, here we go. This will help me. I'll have to do it in Erlang land. Because I don't know how to do it outside of Erlang land at the moment. Okay, so we need to start this. Cool. Then we need to connect. Then we need to generate our register message. Like so. And then we need to, should learn how to do this more readily in the future too. So we're going to send a message which should have send the message, which is the register message, which should have created okay, it doesn't create them in a way we can reach them, I guess. Huh. Okay, let's do something different here. Okay, so down here we're gonna say handle message broadcast. It's gonna take, I believe, a username and a message, I think. This is gonna be the state, and the state better match the username. this. All right. And then we need to get the this can't possibly be the right way to throw out an error here, but maybe it is. I think this is supposed to be like something else. Anyway, it doesn't matter. Um, well, it seems to be working because I do a test, so it should be fine. All right, then if we do this, we need to get our processes. That's not how you do this. We're going to do pg get members from the broadcast group. And we are going to, for each of them, send the message, right? So we just do, oops. So this is going to have the PID. Then we just do PID. What do we send? Broadcast. Right. Okay. So this is going to send the message as a handle for the handle info. So we're going to have to write a handle info function which accepts the broadcast, the username, and the message like this. And then that way we can just write it to the console. So like username set us this message or whatever. Because that's basically what's going to be broadcast. Right. So we can just call this PID broadcast. And we don't use the username. Why is this? Interesting. So what is the equivalent? So Erlang send processes send Erlang send. This is destination is probably PID message is a great. So this can be Erlang send PID broadcast. What are you talking about? I guess it just doesn't know that this is a PID. How would I even tell it? How would I begin to tell it that it's a PID? I don't even know. So I don't think there's really anything we can do about this. I think we should just try this and be done with it, even though it's complaining. Okay, and then after we do this, we're just gonna say like, okay, state, because there's nothing else we need to do. Apparently, I know it's unused, but like the point is I want to match. These should match. It's kind of annoying that this is also complaining at me. Oh, okay. I could just use username. That's true. That's totally illegal. And they still have to match, I believe. Oh, you know what? I have the wrong casing. So let's see if this complains. It doesn't. Great. I'm just dumb. Ignore me. Okay, cool. So I'm not convinced that this is going to work, but I don't really know how to indicate to lists for each that PID is actually like coming from this processes, which should be a list of process. So unsure how to deal with that. So we'll just do that. Hey, Roasted, what's going on? So now we have a handle info, which needs to handle that new broadcast message. So broadcast, and then we're gonna get username, and we're gonna get the message, then we're gonna have the state. That is not the correct syntax. So when we get this message, all we need to do is do like IO. It's logger notice username. Nice. Yeah, unfortunately I'm not doing Elixir, I'm doing Erlang, but like conceptually they're very similar languages obviously. So if that sends you away, I apologize, but I'm just a big fan of the Erlang syntax. Like we're essentially interconverting between Elixir and Erlang because they're such similar languages. There's just a few things that are missing when you go one way or another. So yeah, like for example, one thing that we don't really have an easy way to get is so in the Elixir version of this code, there's this registry where you can put like so I should back up just a little bit. We're building basically a TCP chat server right now, and we're getting towards the end, and what we're doing is setting up this broadcast registry so that every time a client connects to the chat, we keep track of the PID that handles that TCP connection. So what we're going to do is basically register all the PIDs that are connected and then broadcast a message to all of them. And then the other piece of this was we were going to create this registry for a username, but we can't create like a unique registry. So I'd have to do like a bunch of work to ensure that whenever someone tries to register a username, it's unique. And I don't think it's that like relevant to have a unique username in this like example chat TCP server. So I'm just not going to do that basically. And we'll just use the broadcast registry just to see if it works. Okay, so anyway, the username will send the message, and like this isn't formatted beautifully, but I don't. Again, we're not creating like uh a real chat server. We're just creating like a test chat server. So I think this is fine. Yeah, nice. Yeah, I would like the chat server thing to be like really easy for me to do. I think right now like network programming in general is pretty hard for me. So I think it'll be good for me to have some practice here. Okay, so actually what I want to do is close this because there was no reason for me to open it, and then we'll open up the chat protocol test. This no, not this one. This one. Yeah, it's like such a good example. Okay, so in theory, this is working now. So let me move this off the screen for a second. And then we're gonna open up. Actually, I shouldn't do it this way, otherwise you won't be able to see. So let me put this up here and go like this. All the things. It's so hard to grab this. Here we go. So anyway, here's our first chat server. So we're gonna do rebar3 shell, and then we're gonna do chat acceptor start link. Okay, so now Our chat acceptor is started. Oh, right. Oh, this is going to be problematic. Oh. Okay, so let's see if we can do it. I'm not 100% sure at the moment. The reason that I'm not sure is because, oh, well, we can do 2 clients from the same thing. Hey, Bigger Geek, thanks for following. Appreciate it. Oh, Roasted also followed. Appreciate you. Wait, did I already say that? Yes, I did. I didn't say it in those words. But anyway. Okay, so I'm lying to you a little bit. We can't really do this from 2 nodes. The reason we can't do it from 2... Okay, terminology. If you have 2 rebar 3 shells, these are referred to as nodes in Erlang. So there are nodes, and then there are... I forget what the one above node is even referred to as. But you can connect these things very easily. However, the way my chat acceptor is set up, it's only gonna work locally. It doesn't have it's not registered globally. And so to like get these things connected, it's gonna be a little annoying. So instead, what I'm going to do is just create 2 clients. So we'll have like 1, and then we'll have 2. So you can see that these are like different connections to the chat acceptor. And then we'll create 2 register messages. So the first one will just be like chiroptical, and I should have changed this. We'll just use message for the next one. And Ryan, you had the last message, so you're gonna be the other message. So then we're gonna register these. We can say okay, gen TCP send 1. I'll be 1, I guess. I guess it doesn't really matter. And then we'll say gen TCP send to message like this. So now in theory, we have 2 people registered as clients. And then we can say like, here's a chat, which is going to be chat protocol broadcast. And we should take the username. I guess you don't really need the username. Oh yeah, you do, because I need to know who sent the message. So if we do this and the message, hello world, we should be able to say, okay, gen TCP send 1, chat 1, and it explodes. Lovely. Let's see what I broke. Well, first of all, it worked. Then it exploded, which is good, I guess. So we see 2 of these because there are 2 connections. Ideally, you would see these in separate windows, right? Like we would have 2 nodes connected and you would be connecting, but then it exploded for some reason. Last broadcast message was the server state was Ryan, bad return value. And then the same thing happened over there. Bad return value. Why don't we have a useful stack trace here? Okay, so somewhere we return an okay state, and what we're not supposed to. So let's look for okay, comma. Well, I can't do it that way, apparently. Maybe I need this. Okay, so this one's fine. This one's fine. This one's fine. Oh yeah, I guess that's true. Maybe this does imply that it's there. So let's see if we can find the bad. All right, so the init, that definitely returns okay state. That's fine. Okay, this is probably what's wrong. So what I don't understand is why it's wrong. Okay, where do we call handle message? So possibly. So handle new data is going to call. It's going to call handle new data recursively until what? Until we hit this incomplete message. Huh. No, there isn't. You're 100% right. So, if you look at this code, what's happening or what's supposed to happen is that we call handle new data on the state until we hit this incomplete message. So the point then we return like no reply with the state. So this really only needs to return okay with the state or error. Um, so to me, it looks like it's correct. Because we have the state and then we just send out the broadcast messages, we return okay, and then we'll attempt. Let's read this. Decode message, buffer, new buffer takes the rest. Yes. So this is going to return okay. It's going to recursively call handle new data. It should get an incomplete, and then it should respond with no reply. So I think that it's not here. Somewhere else, I think we're returning okay. Here, handle. I found it. Yeah, same. It's the same problem, by the way, but it's just a different line. I was looking at the wrong place. So that needs to return no reply state, not okay. Nice. It'd be cool if I'm surprised actually that we don't get an error from ELP here because I'm pretty sure it's still running anyway. Okay, it might be broken, but I would have guessed that this is an invalid, like okay here is just an invalid type, and so I'm surprised that ELP doesn't yell at me. All right, anyway, let's try this again. I think this is all broken, so I can't do this again. But we want to say, let's see if I can do this from. I highly doubt I can, but chat acceptor start link. Then we want to say we need to create our registers. So one register. Yeah, so ELP I'm pretty sure is just using dialyzer underneath the hood. It's using oh no, it's using the other one, gradualizer, I think is what it's called. So chat protocol register hieroptical. Do register is going to be chat protocol register bigger geek, and then we'll have 1M is just going to be chat protocol broadcast. It's kind of funny that these don't actually need to. Hello, bigger geek 2M protocol. So there's a few nice things about this. Okay, and then now that this is started, we can say we need to create the clients. So one client is gen TCP connect localhost binary a2 connection gen connect localhost binary. Okay, and then we can do CP send one client 1R. CP send two client 2R. So those are the register messages that just tell the TCP connection who you are. And then from there, we can say gen TCP send one, what did I call it? I think I called it message on R. So we should, it's 1C. Is this still going to be broken? Shoot. Okay, that's really unfortunate. Just start copying and pasting. Sorry, y'all. I wish that it like was a little more resilient when you make mistakes. I don't really know how to make it more resilient, but it would be nice if it. Sorry, the client comes before the message in the argument list. Oh yeah, you're right. Good catch. Yeah, either way, I did definitely the wrong. I didn't even do the right thing, even close to the right thing. So it's hard when your names don't really mean anything. Okay, so anyway, now we can say gen TCP send one client, one message. Nice. So Chiroptical says, hello, bigger geek. And then we should be able to do gen TCP send to client to message. And then Bigger Geek says hello chiroptical. There we go. Two shells, both connected. Two TCP connections, both connected to one chat client, sending each other messages. Ta-da, we did it. Oh, okay. And 1 second. Let me see if there's anything else left in this chapter. Bring this back up here. This is just a test. We just did a test. We could save it. Yep. Connect user. Sure, we could write some functionality to make this easier. Obviously. Okay, so then we'll build a client to actually just attach to the product to the piece. So actually, it's very likely that it doesn't even matter. Oh, fun. That's a really good point that I did not realize just a moment ago. Um, even if why is this failing? Oh, okay. So actually, I know why that's failing. So we need to turn this thing automatically starting off. So this echo server, we don't want to run all the time, but we do want the process registry to run. So let's comment that out. And so now we should be able to do this and then run chat acceptor start link here. And it doesn't really matter that it's a separate shell, right? So we should be able to say register chat. And then okay, client gen act. Forgot what. How do I write? It's very funny to me that I'm this forgetful. Such is life. Yeah, here we go. Okay. Localhost is what I wanted. Okay. And then this should just work. Now I guess the question will be, where is it going to send these logs? Because the acceptors are here. This is weird, right? I guess we're going to find out. And then we're going to say, oh, no, it's going to happen here, right? Because I'm confused. I'm trying to like predict what's going to happen, but I'm actually not sure where the log is going to get print. Because the manager runs here. We're not sending, we're just logging. We're not actually like sending anything back in TCP, right? So our client is like not really correct here, I don't think. Yeah, 100%. So what we actually need to do is send back. There it is. Okay, I see the trick. My code isn't right. So in this, you can't log this. That doesn't make any sense. You actually need to send the register message. So you're going to have to run gen TCP send state. Oh, we already have the socket. Send the socket the encoded message, which is going to be chat protocol broadcast username message, like this. Right. State. I don't really. So that will get us back where we want to be. Yes. Better. Obviously, the communication has to happen over TCP. Otherwise, we can't send the chat back to the client. And additionally, we don't need to have the right. You can separate the client and the server. Otherwise, this would be useless. If they had to run in the same shell, then, it would be a completely pointless task. Okay, much better. Yeah. That makes so much more sense. All right. So anyway, we're on to writing the client